Lesson 2 on quadratic functions is going to focus on a particularly useful form of writing a quadratic function. So every quadratic function looks like a parabola. Every quadratic function has an x squared in it somewhere. Opens up, opens down, moved around. The form of the quadratic function called the vertex form looks like this. And we had this in our notes yesterday, but we didn't talk too much about it. We just used it to transform a parabola from the basic one to whatever the particular version was. And that was supposed to be a relatively quick way of doing it. And we're going to look at that again today, and I'm going to graph quickly with my calculator, and then we're going to, again, look at all the characteristics, but then what we're going to do is we're going to look at the usefulness of it. So we've been using the form and the transformations, what A does, what P does, what Q does, to sketch, but later on we're going to actually go from a sketch to an equation. So we're going to focus on the pictures at the start, but pretty much half the time we're going to focus on pictures, and the other half the time we're going to try to generate the equation. So if we did like we did last day, if we started off with our basic parabola, and this, I have a bigger graph so I can do 3, 9. So this one right here, we have all of these points, and remember one of the things we talked about was axis of symmetry. So the axis of symmetry for this parabola is x equals 0. And if we know one point on one side of the axis of symmetry, we can find another point on the other side. So when we did 3, 9, 3, 9 is 3 spaces to the right. So therefore, there has to be another matching point 3 spaces to the left. So if you know the vertex, you basically cut your calculations in half. That's the deal. So here's our basic parabola. Now, in this particular example, let's highlight what's happening. First thing, that negative flips our parabola, this parabola, upside down. This thing right here stretches it by 3. So it does get skinnier, but things get multiplied. This number here says our parabola moves to the right, moves to the left 4 spaces. And finally, this number here says every point moves up. So again, we can do our transformations however we want, but I like to go left to right in these particular cases. So first thing, I'm going to sketch this parabola in blue, and I'm going to start off with the vertex, and I'm going to flip that point upside down. Well, it's on the x-axis, so it doesn't go anywhere. Then I'm going to multiply 0 by 3. So again, you can't stretch something that has nothing. But then what we're going to do is we're going to move the vertex 4 to the left. So that's what we get there. And then we're going to move it 1 up. So again, with the vertex, when I flip that coordinate upside down, get the negative, and I stretch it out by 3. 3 times 0 is 0. But then I can move it to the left, and I can move it up 1. So there's that point. Well, how about we look at this one? Again, what we're going to do is we're going to flip it upside down, so it's negative 1. We're going to stretch it down by a factor of 3. That goes to negative 3. And then we're going to move it to the left 4 spaces. And then we're going to move it up 1. And again, I'll just do this with this one as well. It flips to right here. It stretches down 3. It goes over 4, and it goes up 1. Now again, we should know that that's where it's supposed to go, because here is the vertex. Because this point right here, the yellow highlighted line is the axis of symmetry. And again, what we know about the axis of symmetry goes right through the vertex. And if I know one coordinate on one side of the axis of symmetry, then I know a matching one on the other side. So let me just do one more, and then we'll do the matching. Okay, this one right here, we're going to flip it upside down, so it goes down to -4, and then it gets multiplied by a factor of 3, so it's kind of down here at -12, a little bit off our graph, but we can estimate it to be about right there. There's our negative. There's the -12. But then it gets moved over 4. So it moves over to right there, and then it gets bumped 1. So that would be -11. But again, here's what we know. We know that there's a matching one on this side. And if you want to make sure your transformations are good, like moving points around, that's the one. That point up there, -2, 4, ends up down in the bottom. And then what we're going to do is we're going to connect this with our best curve, and that's what that parabola looks like. So again, practicing our transformations from last day, and then we can go ahead and do something. But first of all, I want to look at the graphing calculator. So again, how does our graphing calculator help us? We enter the function, and then we zoom 6, and there's our picture right there. And again, that picture looks like our picture. And if we wanted to use our calculator to make a table of values, we can just scroll up and down, and we can pick any one we want. And here's the ones we have. We have -6, 11. We have -5, 2. We have -4, 1. These 5 right here. So again, our graphing calculator can be very helpful in helping us understand. So let's have a look. Let's use our blue parabola to answer this question. Well, what are the coordinates of the vertex? Well, again, when we count over, the coordinates of the vertex are -4, 1. And what direction is our parabola opening? Well, it's opening down. And what is the equation of the axis of symmetry? Well, there's that highlighted line, which is x is equal to 4. We'll come back to domain and range in a sec. What's the maximum point? The maximum is, again, a vertex word. And the maximum value of this function is y equals 1 when x equals 4, -4, sorry. What is the y coordinate when x is equal to -3? Well, in order to figure that out by hand, without drawing the picture or without our calculator, what you simply do is wherever you see an x in our equation, you plug in the value that you're interested in, and we get -2. But let me just show you something on your calculator. So let me get back to the home screen. If you want to figure out, you have to have entered your y equals. If you want to figure out the value of the function anywhere, so you're not doing a whole bunch of arithmetic, you go second trace and you get to the calculation screen, and you'll see number 1, value. And if we hit enter, what my calculator is saying, give me a value for x, and I will tell you what the value for y is. So when we punch in -3, my calculator spits out -2. And not only does it spit out -2, it tells you where it is. So again, you could use this function, or you can use your table function. So the next question I ask is, what is another point on the graph? Well, you could do this all by hand, but you could go second trace value and maybe punch in, well, hey, how about -5? And that's going to be -2. And how about another one, -2, and that's going to be -11. So again, your calculator can be really helpful of helping you find points, but also help you see these characteristics. So again, -3, 2 is right here, and -5, 2 is right here. We should be able to find one of them if we know the other one. This one down here, we'd have to find, but given that you have that one, you should be able to figure out that one. So this point over here, it's highlighted in red. Well, what do I know? I know it's the same distance down as my negative 2 comma 11, and I know I'm 2 away from the vertex, so I also, or the axis symmetry, so I know I have to be 2 on the other side. So again, we can, based on just simple characteristics of a parabola, we can start to really answer questions really quickly and really simply, but practice is going to really help us. Okay, the domain, remember, domain is a grade 10 thing, and domain is the X stuff that can happen, and parabolas are very easy. The domain is all real numbers. Every single parabola, everything is allowed. So one of the ways you might ask yourself is, is there a number that cannot be plugged in for X? And there's only really 3 kinds of numbers: positive numbers, negative numbers, and 0. And I can definitely plug those in. Now the range is the Y stuff that can happen. And that blue picture has a high point. The highest it will go is positive 1. So everything is not allowed, but everything below and including 1 is part of the range. So again, when you look at things like this, what do you notice? The vertex is really important, because knowing the y coordinate and the x coordinate is important. But look what happens with a parabola. The y coordinate of the vertex really helps us with the range. Oh, look at the x coordinate of the vertex. Well, the x coordinate of the vertex helps us with the axis of symmetry. So again, these are things that maybe you figured out from the homework last day, but we're going to continue on. So again, it's important to understand today how to graph a picture kind of quickly. Hey, find the vertex first. That's the most important thing. And then identify, hey, is this thing going up or is it going down? And then if you had to, you could just find a couple of points and find their matching point, and you will know what the parabola looks like. So our key ideas, again, in this one example, is we have to determine those things like direction of opening. And direction of opening in a y equals ax minus p squared plus q. Okay, direction of opening is the letter A. That letter tells us, is it going to open up? If A is positive, it opens up. If A is negative, it opens down. So that's very important. Again, what about the stretch compress? Well, the stretch compress is not super important with respect to drawing, but there are those questions that I want you to understand. So when A is greater than 1, it's a stretch. And it doesn't matter if you stretch it up or stretch it down. When A is greater than 0 and less than 1, it's a compress. It gets fatter. Well, probably the most important thing, and that's why it's called the vertex form, the vertex of a parabola is P comma Q. And again, I want you to look really quickly. P is negative 4, and Q is positive 1, and there is our vertex right there. So again, we don't have to plot the graph in order to determine the vertex if we know what it is. But again, I want to caution you, you want to be careful with P, because in our formula right here, it's x minus p. So when you have x plus p, you have to make sure that you understand it's the negative of what that value is. Axis of symmetry is simply the x coordinate of the vertex. So it's x equals p. Whatever this is, there is your axis of symmetry. And these are things I want you to look at when you're doing your homework. Just don't believe me. Don't take it for granted. Actually think about them. Domain. Well, this is super easy. But again, you have to see it. You have to believe it. It's always all real numbers. And all real numbers are just all the numbers cube roots, square roots, decimals, fractions, nice numbers, negatives, whatever. And the way you write that is x is an element of that funny looking r. Now the range is a bit trickier, but the range idea is it's related to the y coordinate of the vertex, and it's also related to a. Again, if a is positive, it opens up, and you have a bottom. If a is negative, it opens down, and you have a top. Okay, so let's just have this graph right here, and use those key ideas, and let's have a look at picking off some properties. So the vertex. Again, the vertex is the top or the bottom, and there it is right there. And when you read the coordinate of the vertex, we get 5, comma, -8. Obviously, this graph opens up, and what that means is A is positive, A is greater than 0. The axis of symmetry is the vertical line that cuts through the vertex, and it's a line, it's not a number. You write every vertical line as x equals. Remember, every horizontal line is y equals. Okay, maximum, minimum. Well, that's a minimum because it's a bottom, and the minimum is y is equal to -8 when x is equal to 5. So again, we're looking at the vertex. Is congruent to, well, we're going to come back to this one in a sec, because we're going to have to figure something out. So we'll come back to that at the very end, but what I'm going to tell you is, well, here, let's have a look at it right now. To go from the vertex to your first 2 points, you go over 1 and up 1. To go to the next one, you go over 1 and up 3. And when you look at your basic y equals x squared parabola, so I'm going to do it in red. Here's our basic parabola. And our basic parabola, to go from the vertex, you go over 1, up 1, you go over 1, up 3. So given that these have the same pattern from the vertex to the next point over, then we can say it's congruent to x squared. So it's congruent to our basic one. So sometimes it might be congruent to 2x squared. And finally, the y-intercept. Well, the y-intercept, remember, is the place this thing crosses the y-axis. And on our picture, we can't see it. So the y-intercept is going to be up here somewhere. Now, all we have to know in order to find the y-intercept is, well, we know that the value of this graph is going to, on the y-axis, or where it crosses the y-axis, the x value is going to be equal to 0. So in order to figure out the y-intercept, what we're going to have to do is we're going to have to figure out the equation of this thing. So here's our first introduction of finding the equation of a parabola. And given that we're looking at vertex form, we're going to find the equation of this parabola. And here's what it's going to look like. So that's going to be our start. And what we're simply going to do is we're going to plug in the information we know. Well, I know that this is congruent to the x squared parabola, which means a is going to equal 1, because there's that invisible number 1. I know the coordinate of the vertex is 5 and -8. And that's how simply we can find the equation of a parabola. And we're going to do a few more just to make sure. But basically, this is our introduction to going the other way. If I give you a picture, you have to tell me the equation. So the equation of this parabola turns out to be this. So we're going to do lots of work at school. But for right now, we have to figure out what P and Q is and put them in their place, because that's the P and Q represent the vertex. And if we can simply figure out A, well, we know A opens up, so it has to be positive, and we have to determine what the value of A is. And given that the pattern is the same to go from one point to another and one point to another, and it has to be the same value as our basic one. So in this one right there, there's my equation. And what I can now do, given that I figured out the equation of this parabola in vertex form, what I can do is enter a 0 for x, because the x-coordinate of the y-intercept is always 0, and the only thing left over in solving this equation is y, and what I get is y is equal to 17, which is not the y-intercept. The y-intercept is a coordinate. So again, if we look at our picture, we know that the y-intercept is above 8, because there's our last point we know, so this answer makes sense. So key ideas right now are this notion of identifying the vertex, identifying the axis symmetry, and congruency. And we'll do more of finding the equation in a second at school. Okay, so one last one then, again, about transformations, just to review everything we've done over the last class and a half. What's happening here? So if we have our, relative to our basic parabola, what's happening? So first of all, A. So this thing is still opening up, but it's going to be compressed by a factor of 2. So it's going to be compressed by 2, or another way of saying that, it's going to be half of the original. And by that, we're talking about corresponding points. Well, what's this doing? Well, the plus 1, remember, whenever it's a plus, means it's moved to the left. This thing is going to be moved to the left. 1. And finally, this one means it's going to be moved up. 4. So these ideas of transformations are really important. They help you actually plot faster than doing a parabola. But the key idea is when we go in the reverse direction, which we're going to do shortly, then we need to make sure we understand what A, P, and Q are. We need to know what A, P, and Q do, and therefore our answer is going to make sense if we look at it. So let's have a quick look at writing quadratic functions for each parabola. So I'm just going to give you a little bit of information, and then we're going to have to actually write the equation of the parabola that have these characteristics. And it's always a great idea to make a quick little sketch. So I'm going to make a quick little sketch, and in this parabola, 1, 2, 3, 0 is the vertex, and this parabola goes through 4, -2. So if you looked at this one right here, if this is my vertex right here, and I have a point below, then it has to be opening down. So again, that vertex has to be the top. And if that's the top, then here's my axis of symmetry right here, which means I have a matching point over there. And if I connected those 3 dots, it has to be opening down. So basically what this says to me, my little picture, is A is going to be negative. A is going to be less than 0. And that's going to be important because when I do my computation, that has to be true. So in my basic equation, again, we're looking at vertex form of the equation. It's very important that we understand what we have. Well, here is my P, here is my Q, and we're looking at this thing right here, and what we have to figure out is A, but we have an X and a Y. So if I went ahead and plugged in right now, here's what I definitely know. I have a times x minus 3 squared plus 0, and you don't really need the 0. So here's what we have. But this looks to be a problem because I need to find a, but I also have an x and a y I don't know. But here's the other important thing. I do know one other coordinate, and that other coordinate is literally an x and a y. So what we can then do now is we can plug the x coordinate where the x goes, and the y coordinate in the y space. And when you do that, what you have is one equation with one unknown, and we can go ahead and answer the value of a. So what we end up with is negative 2 is equal to a times 1 squared, which is 1a, and obviously that is our value of a. Now again, I want to emphasize, by making a quick little sketch, we understood a would be negative. It is negative, so we think we're right. And finally, we just have to write the actual equation. Y is equal to negative 2 x minus 3 all squared. And you could put 0 if you wanted, or you could just leave it alone. So here's our going the reverse direction. Instead of A, P, and Q telling us things about the parabola, so we could draw it, we are using information and coming up with the equation. Okay, one last one. Quick little sketch. Here's my vertex at 1, negative 1, and we have a y-intercept at 3. So 1, 2, 3. There's my y-intercept. Again, my axis of symmetry is right there, which means I have a matching point at 2, 3. And when I look at that, what I see is the parabola is opening up. So a is going to be a positive number. And then we go ahead and we put the right things in the right spot. I'm going to do it a bit quicker this time. We know P and Q, and we know, well, X and Y. But again, we only know X and Y if we know that the y-intercept is a coordinate. So 3 is our y value, a is an I don't know, x is 0 minus our p-value in our vertex plus negative 1, so I'm just going to make that negative 1. And we end up with 3 is equal to a times negative 1 squared minus 1. Negative 1 times negative 1 is positive 1. Add 1 to both sides, and we get a is equal to 4, which we understood would have to happen. And now we plug all of our a, p, and q. And there is our equation.